It looks like I'm recording, so I'm going to get started. So for the past couple of weeks, we have been working primarily with Mendelian traits and crosses. The organism that I was assigned was the wild mice population, and within this population, we only have one trait, that trait being fur-linked. And since we only have one trait, that means we are going to be doing monohybrid crosses. And as you can see here, this one trait has 3 different outcomes. So that should automatically key us in that we are working with multiple alleles. And so the 3 different outcomes for our fur length is short fur, medium fur, and long fur. My hypothesis is the trait for fur length is inherited with an autosomal dominant recessive with multiple alleles pattern and should follow the first law of inheritance. So here's a couple of the crosses that I did. The first one was both short fur heterozygous male and female mouse, as well as both long fur heterozygous male and female mice. And if you're wondering why there isn't a heterozygous or a both medium fur heterozygous male and female cross, is because simply a medium heterozygous mouse doesn't exist. The only way you'll have a medium fur mouse is if you have a double O allele, and we'll see that in a second. So here's a couple of the predictions. Here's the first cross that I did with a heterozygous short fur mouse with an A and an O allele. And as you can see here, this double O allele is where our medium fur mouse comes into play. And if you look right here, you have an A and O allele, but this mouse comes out to be short fur instead of medium fur, since the short fur overall dominates the medium fur. And so our prediction for this cross would be a 3-to-1 ratio, 3 being short fur, 1 being medium fur. Our observed outcome was 107 to 33, when our expected was 105 to 35, which is very similar. And here's our next cross for our heterozygous long fur mice with a B and an O allele. And here again is our double medium fur mouse, or double O allele medium fur mouse. Our prediction for this cross is a 3-to-1 ratio as well, 3 being long fur and 1 being medium fur. And let me also add that you look right here, the B and O allele, this mouse comes out to be long fur. So that means that the long fur dominates over the medium fur, just like the short fur did. And our observed outcome was 77 to 29, when our expected was 79.5 to 26.5. And these numbers are also very similar. And here's another one of our predictions where we're doing a heterozygous short fur mouse with an A and a B allele. And so here our prediction would also be a 3-to-1 ratio, 3 being short fur and 1 being long fur. If you look right here, you'll see that our A and B alleles, when they come together, the short allele, the A allele, dominates over the B allele, which is the long fur allele. So that overall means that the short fur is our main dominant allele. And our outcome for this, our observed, is 121 to 49, while our expected was 127.5 to 42.5. And these numbers are also very similar. And we're going to move on to our predictions for our F2 generation, which is when we cross a heterozygous short fur mouse with a heterozygous long fur mouse. So these have an A-O allele as well as a B-O allele. And our prediction comes out to be a 1 to 2-to-1 ratio, 1 being medium, 2 being short, and 1 being long. And our observed outcome was 28 to 82 to 33, while our expected outcome was 35.8 to 71.5 to 35.8. And if you do a chi-squared analysis on these numbers, your p-value will come out to be 0.2, meaning that the difference in these numbers is not significant. So overall, you can see that our short fur dominates over our long fur, and long fur dominates over medium fur. And that's the pattern in these alleles. And our conclusion comes out to be that the observed data is a good fit for the ratio predicted. Therefore, we fail to reject the hypothesis, which is autosomal dominant recessive with multiple alleles pattern. And our differences between observed and expected numbers is not significant according to chi-squared analysis. And that pretty much wraps it up. I'm going to stop here.